The Mannin-Binding Lectin pathway is homologous to the classical pathway. The MB-lectin pathway uses a protein very similar to C1q to trigger the complement cascade. This protein, called the Mannin-Binding Lectin, MBL, is a colectin like C1q. Mannin-Binding Lectin binds specifically to mannose residues and to certain other sugars which are accessible and arranged in a pattern that allows binding on many pathogens. On vertebrate cells, however, these are covered by other sugar groups, especially sialic acid. Thus, Mannin-Binding Lectin is able to initiate complement activation by binding to pathogen surfaces. It is present at low concentrations in normal plasma of most individuals, and its production by the liver is increased during the acute phase reaction of the innate immune response. Mannin-Binding Lectin, like C1q, is a six-headed molecule that forms a complex with two protease zymogens, which in the case of Mannin-Binding Lectin complex, MBL complex, are MASP1 and MASP2. MASP1 and MASP2 are closely homologous to C1R and C1S, and all four enzymes are likely to have evolved from gene duplication of a common precursor. When the MBL complex binds to a pathogen surface, MASP1 and MASP2 are activated to cleave C4 and C2. Thus, the MB-lectin pathway initiates complement activation in the same way as the classical pathway, forming a C3 convertase from C2b bound to C4b. People deficient in Mannin-Binding Lectin experience a substantial increase in infections during early childhood, indicating the importance of the MB-lectin pathway for host defense. The age window of susceptibility to infections associated with Mannin-Binding Lectin deficiency illustrates the particular importance of innate host defense mechanisms in childhood, before the child's adaptive immune responses are fully matured and after maternal antibodies transferred across the placenta and in colostrum have been lost. And that's the Mannin-Binding Lectin pathway is homologous to the classical pathway. Have a great day.